Hi students, let us now take a look at question 5C from exercise 10B. Right, so this is another question from this weekend's homework. Okay, so we're asked to solve the equation 15 over sine square theta equals to 5 minus 31 over tangent theta. Okay, for the range of angles between negative 360 degrees to 0 degrees. Okay, so if you look at the this particular question, okay, there are several things that you may be thinking of. Okay, so one thing that you may be thinking of is to replace this sine square theta, right, with 1 over cosine square theta, then you will end up with this, right? Okay, 1 minus cosine square theta equals to 5 minus 31 over. Okay, then some of you may be thinking, since I've converted to cosine square theta, then why not also convert this side into maybe in terms of sine theta and cosine theta. Okay, so whenever you take such make such decision in solving a trigo equation, you always need to ask yourself whether does it serve any purpose or not. Okay, if you look at the original question and this question, after you have performed this step, right, the equation actually became even more complicated than what it started with. Okay, so whenever you want to solve a math question, we try to not to go into a direction whereby we are making the question more and more complicated. Right, of course, there will be cases whereby sometimes the equation may get slightly more complicated first before you can simplify it again. Okay, but if you look at this particular case now, I don't think it's going to help much, because if you try to group everything on this right side together, okay, it's going to be rather messy. And then after that, you want to think of cross multiplying, and you want to cross multiply to 1 minus cosine square theta on the left side, right? Okay, the whole expression is going to get complicated, right? So at this point in time, you realize that over here we have two things that are at the denominator. So you may try to think of some ways to get rid of the denominator. Okay, so over here I should express this 15 over sine square theta in this form. So actually 15 over sine square theta is nothing other than 15 times 1 over sine square theta, right? And then this 31 over tangent theta is just 31 times 1 over tangent theta. Right, so is there anything that we can do to convert this 1 over sine square theta into something else? Okay, then what should come to mind now would be that cosecant, right? Because cosecant, okay, we know that cosecant theta is 1 over sine theta. So if we have 1 over sine square theta, then it just goes to say that the left side will be cosecant square theta. So why not we use this to convert, okay, to replace the 1 over sine square theta. Right, so you can replace this with cosecant square theta. Okay, then you may be asking, right, but how does this simplify the question? Okay, but if you think about it, at least after this step, we have gotten rid of a denominator. Okay, so now it's just 15 cosecant square theta. Okay, so can we since we are at this point of view, okay, this train of thought of getting rid of denominator, right? Can we also get rid of the denominator, tangent theta? So 1 over tangent theta will be what? Okay, so cotangent theta, right? We know that cotangent theta is 1 over tangent theta. Okay, so why not replace the 1 over tangent theta with cotangent theta also? So we will end up with this. You see, in one step, okay, we have gotten rid of the denominator. And this has simplified the question to some extent. Okay, then the moment you see, next part you observe cosecant and cotangent together. Is there any identities that can connect them together or not? Yes, there is, right? Because we know that cotangent square theta plus 1 is cosecant square theta. So now we can replace the cosecant square theta with cotangent square theta plus 1. And the whole equation is now in terms of cotangent theta. And then it will become just like the previous two questions, right? Alright. Okay, so the aim is always to convert everything, okay, in the equation, right, to be in terms of just one type of trigo function. Right, so now we're going to expand and then bring everything to the left side. Okay, so if we expand, we get 15 cotangent square theta plus 15. Okay, bring everything to the left side, minus 5 plus 31 cotangent theta equals to 0. Okay, so we end up with 15 cotangent square theta plus 31 cotangent theta plus 10 equals to 0. Okay, so now we're going to try to introduce a substitution and then try to factorize this. So let y equals to cotangent theta. So we'll have 15y squared plus 31y plus 10 equals to 0. Okay, so let's try to factorize this. Okay, so 15, we'll try 5y and 3y, and then we see whether we can factorize it. Indeed, we can, because if we have plus 5 here, we get a 25, then plus 2, another 6, so to give us the 31. Okay, so from here, we can solve already. So either 5y plus 2 is 0, so y equals to negative 2/5, or 3y plus 5 equals to 0, y equals to negative 5/3, right? Okay, so now we can substitute in cotangent theta. Okay, so if cotangent theta is negative 2/5, then we flip it, tangent theta will be negative 5/2. Right, then from here, of course, we'll go and find the basic angle. Tangent alpha equals to 5/2. So alpha is the basic angle, so we will get alpha equals to 68.20. Okay, we'll just leave it at this point first, and then we find the basic angle for the right side first, right? And we'll discuss both at the same time. So from here, cotangent theta is negative 5/3. So tangent theta will be negative 3/5. So same thing, we'll find the basic angle for this. So basic angle would be 30.96. Okay, so 30.96. Okay, so this part you got to be careful. Got to look at the range again. So the range is from negative 360 to 0 degrees. So in other words, we are finding one round also, but we want to go negative direction for this round. Okay, so tangent is negative for both. Okay, so a bit more convenient. Tangent is negative for both, so we'll be interested in the quadrants S and C. Okay, so that means second and fourth quadrant. Right. So let's think about this. So in the second quadrant, the basic angle will be here. Okay, the basic angle will be here. This time we are searching the negative direction for one round, so we got to go this direction. So that means the angles that are in the second quadrant, right? Okay, will be negative 180. Okay, then add on another negative alpha. Okay, so let's find the angle. So alpha will be negative 180, then minus away another basic angle. Right, so we'll do the same thing for this. Sorry, this one is not alpha, this one should be theta already, right? Okay, so theta. Okay, same thing for here, theta will be negative 180 minus another 30.96, right? Okay, the next angle that I want to find will be in the fourth quadrant. Okay, this is fourth quadrant one. That's the cosine quadrant. So that this one easy because the basic angle is here, and the general angle will just be this. So that means the general angle will just be negative of the basic angle, so negative 30.96. Okay, so from here we will be able to get the four answers, right? So theta would be, okay, so the most negative one would be this one. Okay, so we'll write this one first. You calculate out, you get negative 248.2. Okay, followed by this one, which will give us negative 211.0. Okay, followed by this negative 68.20, and then finally followed by this negative 31.0. Okay, so all of these are to 1 dp. Right, so this is how you solve a question like this. So always the most important part is the first part. Okay, think about how you can simplify the equation. Okay, without making overly complicated. Right, so always think about the identities that you want to use, okay, or how you can convert it to simplify the equation instead of just simply looking at the question. You see a sine square theta, then you just anyhow use some identities. All right.